This video is about solving two-step inequalities. Are the steps similar to solving equation? That's the question we first need to answer before we start looking at problems. So I'm going to tell you yes and no. There are some similarities, but there's also a difference. Let's take a look at the yes first. We are going to keep the same steps. We're going to do step one, which is to use inverse operations with the term that has no variable. In other words, that is the constant, on the same side of the equation where the variable is. So we're going to be doing some adding or subtracting. Step two, we're going to use inverse operations on the coefficient of the term with the variable. In other words, we're going to multiply or divide. So those two steps haven't changed, very similar to equations. What changes is we have to remember the new rule that came into play with inequalities. When you multiply or divide by a negative number, you flip over the inequality sign. The reason that occurs is because, remember, a negative sign means the opposite of. So when we're going to multiply or divide by the opposite of something, instead of it being less than, it becomes greater than, or instead of greater than, it becomes less than. So we want to keep that in mind about inequalities. So let's take a look at this problem first here. X divided by 3 minus 11 is less than or equal to negative 4. So I'm going to divide my sides up here. And my first step is I'm going to add 11 to both sides. Now, once I do that, I can take a look at this and I see that I have a zero pair right there. So I don't care about that. And all I'm left with is x divided by 3. I have a negative 4 plus an 11, which is equal to 7. Adding 11 to both sides does not change the sign, so we're going to keep it. My next step is I look here and I see x divided by 3. So what I want to do then is the inverse, which is to multiply both sides by 3. Once I do that, I see that I get a big 1 right there, and 1 times x is x. 7 times 3 is 21. And since I did not multiply by a negative number, I am going to keep the same sign I had. So x is less than 21. That's what we feel the solution is. So what I'm going to do is we're going to check our solution. That's what we always do. We did that with equations. We'll do the same thing here with inequalities. We're going to take our answer and put it in the spot where the variable was. And just like equations, we are going to keep an equal sign here when we check, because we want them to be equal if this is the right number that we were to come up with, or the right, what they call the bounds. So 21 divided by 3 is 7. And 7 minus 11 is negative 4. So since that does check out, that means x is less than or equal to 21 is our solution for this inequality, but we need to graph this inequality as well. So we're going to have a 0 and we're going to have a 21. We're going to have a closed circle at 21 because of this equal sign. And then what we're going to do from there is we have to decide, do we go right or do we go left? So what we're going to do is we're going to take our 0 test and put in 0 for x. So 0 is less than or equal to 21. That happens to be true, and because it's true, we're going to take our line towards the 0, because 0 is an answer. 0 is a possible answer. Okay? Going on to this next problem, example 2, I have negative 5f plus 11 is less than or equal to negative 4. So I'm going to separate my sides once again so I can focus on where my two steps are. So here I see a positive 11, so I'm going to subtract 11 from both sides. What that does is it gives me a 0 pair right here, and it makes it go away. So I'm left with negative 5f, and a negative 4 and a negative 11 is negative 15. So I'm going to keep the sign because subtracting 11 does not change the sign. My next step, since this is multiplying by negative 5, I'm going to divide both sides by negative 5. We know, though, dividing by a negative does flip that inequality over, so from going from less than or equal to greater than or equal to. Here we have a 1. 1 times f is just f, and negative 15 divided by negative 5 is positive 3. So we're going to check our solution to make sure that it works. So we're going to take that number of 3 and we're going to put it in the inequality, which we're going to turn into an equation for our check, and follow the order of operations. Negative 5 times 3 is negative 15, and negative 15 plus 11 is negative 4. So that works out. So this indeed is our solution. and we need to put the number 0 on our number line so that we have a bounds, and we have 3. So we look at and we see that it has an equal sign, so we're going to put a solid circle at 3, and we're going to do the 0 test. So 0 is greater than or equal to 3. Well, since this is false, that's false. We're not going to include 0 in our answers. That means we need all the numbers larger than 0 in our answers. So we're going to go towards the right this time. So that gives you an idea of how basically it works with two-step inequalities. Now let's take a look at some word problems and how this is going to pan out. So Ed wants to bicycle at least 75 miles this week and has already biked 11 miles. We're going to write an equality to find the average number of miles he should bike on his remaining 4 bike rides this week. Then we're going to solve and graph the solutions. So let's take a look at some key components. He biked 75 miles this week. He's already biked 11 miles. He wants to do 4 more bike rides this week, and we need to know the number of miles he should bike. So these are crucial things that we need to know. So let's write down and put this to terms. Let's try and create this inequality. So we know he has 11 miles already, and he needs to bike 4 more times this week. And we're going to put X to be that number of miles he should bike. And we know total he wants 75. So we just have to decide on the sign. He said at least, which means he wants at least equal to that, and he wants more than that, so greater than or equal to 75. So now we have an inequality we can work with. So we've done step 1, which is to write an inequality based on the story. So I'm going to bring my little line over, and we're going to separate our sides, and now we're going to solve this. So instead of adding 11, we're going to subtract 11 from both sides. What that does for us is gives us a 0 pair here, and I'm left with 4x is greater than or equal to, and this becomes 64. Now remember, we only subtracted 11, so that's not going to change our sign. So we're going to divide now both sides by 4, and when I divide both sides by 4, that also does not change the sign. So we're going to keep that sign of greater than or equal to. This becomes 1, and 1 times x is x, and 64 divided by 4, it's going to be 16. Okay, so this is where we're at here. So now what we're going to do is we are going to check our solution. So we're going to take this number 16 and we're going to put it back into the original problem. 11 plus 4 times 16, is it equal to 75? Remember, we always change it to equals when we're checking. So 16 times 4 is 64. And 64 plus 11 is indeed 75. So far, so good. This x is greater than or equal to 16 is looking good. So we're going to put it on our graph. We're going to have a 0 and a 16. Because it needs to be equal to that number, it's going to be a closed circle. We're going to put our 0 test in there. We find out that that is false, so we're going to go away from the 0. So the minimum number that he can do every day is 16. He can do 17, 18, he can do 20, and he will meet his goal. But if he goes less than 16 every day, he will not meet his goal. Okay, let's try one more just like this, very similar. Here we have Dina is buying lunch for herself and 2 friends. She has a coupon for $15 off the total bill and wants to spend less than $49 after using the coupon. Let's write an equality to show how much each lunch costs, solve and graph the solutions, and then we're going to determine if $21, $22, or $23 are any of those possible solutions for Dina's problem. So first thing we need to do is identify some key things. We have Dina and 2 friends. So altogether, there are 3 people going to lunch. She has a coupon for $15, and we have to remember, so I'm going to write some things off to the side here. We have 3 friends right here. We know a coupon means that we're going to subtract. So we got to keep that in mind as well, too. Okay, she wants to spend $49, but she wants to spend less than $49 after the coupon. So she doesn't want to spend any more than that. So let's create an inequality just based on that much information. So we have 3 friends. Dina and her 3 friends. She's going to spend so much on each lunch. She's going to subtract a $15 coupon, and she does not want to spend more than she wants to spend less than $49. Okay, so there's our inequality. So what we're going to do is we're going to solve this inequality. Okay, First step is to add 15 to both sides, and that does not change our direction of our inequality. That's going to stay less than. This is going to stay 3x on the left side because this is a zero pair. And then we add these together, and I'm going to get 64. Okay. Next step. Okay, our next step is we're going to divide by 3, both sides. Now, when we do that, dividing by 3 doesn't change the sign either. This stays to be x. Now, 64 divided by 3, this is going to go in 21, and it's going to keep repeating. So 3, 3, 3, 3, 3, 3, 3. That's what we're looking for. So it's going to be difficult for us to check it, but we're going to try. We're going to try our best. So what we're going to do, we're going to keep the less than sign. Because of this fraction, we're going to keep the less than sign, and I'm going to put the number 21 in there to see if that's going to hold, okay? Because I want less than this number anyways. That's what we're saying. So let's try that. So 3 times 21 minus 15, is that less than 49? And we know 3 times 21 is 63. 63 minus 15 is 48. And 48 is less than 49. So we know this is a good number. So we're going to put 0 on here. We know this is going to be 21 and a third. That's basically what's going on. 21 and 3 repeating is a third. We want open circle because we don't want to include that $49, right? We're talking about how it's going to be less than that. And so anything less than this is going to work. Okay, anything less than this. So 0 will work because 0 is less than that. So the question is, are any of these possible solutions $21, $22, or $23? $21 is a go because $21 fits the bill. 22 and 23, those are not going to work because $22 is more, $23 is more. So $21 is the only solution of those 3 that would work for this particular problem. Hopefully you understand a little bit more about solving two-step inequalities.